Okay, I'm sorry. I probably threw my voice a little while ahead. So yeah, so we're going to set the stage. We're going to talk about a few concepts, and then I'll get into some internals and talk about stuff that matters. I'm going to touch upon data modeling guidelines. There was a great talk in the same room just a while ago on the data modeling, and I was just saying that, hey, thank you, because it exactly said what I wanted to say, right? And then we'll talk about 3 generic use cases, and that's the one that I would like to concentrate my time on. So let's get into that. Just a little bit about myself. I've been in the Oracle, in the database world for a long time. I've been using Oracle since Oracle 5.1.22. That's about 30 years ago. I'm sort of dating myself in terms of how long I've been in this industry. I've been using NoSQL for the past 4 years, right? And I work at PayPal now. PayPal has given me the opportunity to explore and work on this new product. And I'm passionate about sharing my information, things that I know. This was sort of translated into some of the books that I participated in as co-author and as technical editor. So by a quick show of hands, how many of you are using Couchbase in production? Okay, that's a fair number. Any other NoSQL technologies? Okay. How many of you are considering Couchbase or any other NoSQL for use in your, okay, just a few. So if I can characterize the group that is here, some of us are quite new to NoSQL and to Couchbase, so I will dwell on some of those concepts a little bit deeper. In one particular slide, I will sort of look at the differences between SQL and NoSQL, right? So let's get into this. A little bit about what PayPal does. PayPal uses a polyglot of database technologies. We're primarily Oracle RDBMS, but we also use NoSQL, Couchbase, Cassandra, Aerospike, and MongoDB. And these are best uses for certain use cases. So we take the right technology to use for the right use case. In terms of the usage, Couchbase was one of the earliest NoSQL technologies that PayPal started with, 2013. So we've been using it for quite a while. We are currently on Couchbase 4.1, and we will plan to move to 4.6 or 5.0 next year. We have a large fleet. We have been talking at Couchbase Connect, probably for about 3-4 years now. So you can see some links here in my presentation to the other ones that we have talked. So our database team is about 40 plus people. We are organized by different teams, architecture. So I belong to the architecture team. We have engineering, delivery, and operation teams. We work across multiple geographies, and we all collectively support these polyglot of technologies. That by itself is a challenge for having a large fleet of people understand and use different database technologies. But that is what we need to drive to. We cannot continue to be specialists in one particular area, right? So if you're here to learn Couchbase, then this is the right place to be, okay? Right. So before we start, I'm always a firm believer that you should understand concepts, and understanding these concepts are key. So if you look at the documentation, you will see a section which is devoted to concepts and architecture. And I urge you, before you get deep into things, to study this in detail. It's going to cover most of this. There are some pieces which are not available in the newer 4.6 that I will kind of talk about. So there are a few things that I listed here: replication, rebalancing, TTL, views, configuration parameters, and deployment options, which matter when you talk about deploying a successful Couchbase project. So in my mind, the RDBMS versus the NoSQL is not a zero-sum game, right? We can continue to coexist. And as technologists, we are expected to understand all these technologies. But I would add a little caveat here by saying buyer beware, because what applies to me as my use case may not apply to you, right? What we're going to talk about is generic use cases, and hopefully you'll pick some tips up from that. So the presentation flow, ask questions during the presentation. I will repeat it, but please keep the question relevant to the point being discussed, right? If I find that there's something that the question gets into a deeper mode and deeper information, then I would sort of ask you to pause, and then we'll deal with it at the end, or I can direct you to the right Couchbase person. Okay, good. So this is what I call my 4x4 slide, and I sort of use this for quite a while, and this is what I do, right? So we have a traditional RDBMS. It provides ACID capabilities, atomicity, consistency, isolation, and durability, and we have got used to that. But we pay a cost for that, and that's scalability, right? So most of the scalability in the traditional RDBMS world is to scale up. But we are in this world where we got to expand very quickly, and from that perspective, we are held back a little. There is native sharding sort of being built into these products, and you will see that the RDBMS world is trying to get to the NoSQL world, and the NoSQL world is getting to the RDBMS world, but traditionally, the larger, older DBMSs do present some challenges here in this case. But what are the advantages? ACID. We talked about ACID as something that probably holds back some of the traditional RDBMS, but ACID is essential in many cases. And this is key to understanding why we live in this polyglot world, right? So we have to pick the right product for the right use case. It supports a complex data model because there are cases where you do need to have a large, complex data model. It is a mature technology. The ecosystem is very mature. ETL tools abound. There's a plethora of skilled people who are available in this traditional world. But NoSQL came in and came in with its own advantages. As we said, it's highly scalable at relatively lower cost. It's a low latency, scalable KV write, key value pair write, read and write. That is where it shines, right? So Couchbase obviously has multiple products and build that over a layer, but you will see that at the heart of Couchbase, you still have this very, very strong key value pair database, right? That is what I'm going to concentrate on, and that's what we're going to talk about. It also provides a flexible model, data model in terms of JSON, and you have the opportunity to decide which way to go in terms of embedding or linking. And as I said earlier, there's a great talk about that just before me, right? So it supports both an open source model and an enterprise model. You can choose according to what you want. But there are also challenges, right? So there is limited ACID, limited transactionality. The CAP theorem is real. For those who know what the CAP theorem is, let me just quickly explain. When you can either choose consistency or you can choose availability in a partitioned world, in a networked world, right? So that has some interesting, that throws up some interesting problems when it comes to NoSQL. The technology is still evolving, it's maturing, but you have a very fragmented landscape. As I showed in my previous slide, there are a number of NoSQL vendors. Skill sets are slowly building up. As you can evidence in this room, maybe about 10%, 20% are in the NoSQL world, but we need to get there as a community, right? Hopefully, my talk will add a drop of water into this bucket of knowledge that we all need to have in this world where we'll learn and evolve into this new world. Right, so let me quickly move on to what the meat of the matter in this particular thing, right? So Couchbase. Couchbase requires intra-cluster replication to handle node failure within a particular cluster. So you have the opportunity to say how many copies of the data you want to have within a cluster. Typically, you have a master and a replica. It supports you when you have one node failing without data loss. But if you want to have more than one node failure within a particular cluster and not have data loss, you need to have n copies. Obviously, you cannot have as many copies as you have nodes. That's a large overhead. So you need to sort of understand where you want and what is the limit to which you will tolerate failure, right? So inter-cluster replication is another feature that comes out of the box with Couchbase. So inter-cluster replication is called XDCR, cross data center replication, and it supports not just node failure, but cluster failure and more, right? So you can handle cluster level availability, not node level availability. Upgrades, traffic shifts, and so on are very useful. When you want to do upgrades and traffic shifts, a multi-cluster environment helps you. It enables basically one node failure without additional replica copies at the expense of maintaining another cluster, right? So you have additional cluster, additional infrastructure, and you also need to refresh that cluster when you stand it up for the first time, or when there is a large event. You have to think about the overheads of a full XDCR refresh. So what happens when a node fails? When a node fails, if you look at Couchbase, and there are multiple talks about what internally happens in this rebalance operation, there's something called a vbucket which fails, right? So you have a master in one node, copy in another node. A copy in another node in the cluster gets elevated to become the master, and then you need to create replica copies for those copies which are elevated from a replica to a master. That operation is called rebalance, and you need to do that across the cluster. So all the nodes in the cluster will get involved. What we have found is that the rebalance duration is governed by the number of worker threads, and we'll talk about this specific issue, right? Time to live. Time to live, when you differentiate away from the relational world, in the relational world, you might create a partition, range partition table to take care of purging your data. In the NoSQL world, you use something called TTL. TTL is set at the row level, and here is the thing. The DBAs don't control that, the application controls that. And the speaker before me talking about data model talked about the shift in responsibility. So previously, the structure was in the database side. The operations were very transparent in terms of SQL and so on. So a lot of responsibility was on the database server side. In the NoSQL world, this whole thing shifts over to the application, right? So you need to understand that there is the shift going on. In this particular case, an example of the development team setting the time to live for a particular row, right? So where does it matter? If you set a very, very large time to live, then your records are going to live in the database for a long time, so you need to capacitize for that, right? So it sort of indirectly controls the capacity. There is another thing called compaction. What compaction is nothing but the requirement to fill deadwood. So when you have TTL, when a record expires, it leaves holes in the database. When you make a change to a particular row in a bucket, what happens is that this modification is appended to the end of the file, right? So a physical file has sort of holes created by TTL, and also invalid data sitting at the fronter on the more front side of the file. So all of this is repaired through a process called compaction, and that basically is a read of all the files, going through all the old rows, throwing them away, and writing the valid data into another file. So this is write amplification. This is extra I/O during compaction process. And these are things that you need to think about when you look at Couchbase, right? So I briefly mentioned that the documentation, something is missing. I was looking in 4.6, and for some reason, I did not see compaction listed there. So there's something that we'll have to come back and talk to you guys about. So let's see, views. So let me briefly mention this. I'm not going to dwell on the views in GSI for long, because there's been a lot of Couchbase presentations about views and nickel and global secondary index and so on. I just want to point out a few things which you need to know as developers. Both views and GSIs are eventually consistent with the key value pair, right? So that presents an advantage and disadvantage at the same time. So your key value writes are not held up because of the presence of indexes or views, but at the same time, the data that you write there, if you want to read it immediately, it's not available, right? So there is a time gap. So you need to be cognizant of that. Views are something like local partition index, right? So that sits on the view are segmented or partitioned representations of data that is local to a node, which means that if I want to come and do a secondary key access, I need to look at all the nodes and browse through all the view files in every node for me to be able to do that. And this is called a scatter-gather pattern, right? Views are also some of the older technology. They are not on the managed cache as you have with indexes, which means that you are reliant on the OS buffers for read and write in views, right? Global secondary indexes, obviously this is the next generation of indexing. There's been a lot of talks in this Couchbase conference on this. I urge you to take a look at the recorded presentations, but it presents a different set of challenges and a different set of opportunities, right? So let's stop there and then move on to statistics and counters. I'm going to go quickly over this. There is a great console which gives you command statistics over minute, day, hour, week, month, and year, and you can trend and track this. There are specific server resources that you can look at from this console. You might need to supplement that with your own server-side stats. Some of the stats that I typically look at are operations per second. This is a broad overview of the gets, sets, and XTCR operations that are going on in a cluster. So each cluster will have a specific limit to which it can perform well. So trending the operations per second is important from a capacity planning point of view. Right? You can use the YCSP benchmark to determine the threshold level of the ops per second for your cluster, for your particular set of SKUs. That'll give you some rough numbers to deal with when you talk about capacity. Right? There is another set of two other stats that you need to think about: active resident ratio and RAM usage. Now, Couchbase is a memory-first database, right? So you're interacting with RAM, and obviously you need to allocate RAM to the operations that are there. This active resident ratio basically says how well is that RAM used for my keys and for my value, right? There's also a cache miss ratio. The cache miss ratio is the cache hit on the server side, not on your application, but on your server side. So the number of items is something that you also need to track. It is a leading indicator of capacity use for RAM and disk. And you should also track your disk usage, because as I mentioned, when you have a set of documents which mutates very rapidly, you need to append that at the end of the file, and that will show you a temporary disk spike before compaction starts. We talked about queries and views. There are a lot of stats there. XTCR produces another set of stats that you might also want to keep looking at, right? So configuration. When you come to configure a Couchbase cluster, you need to think about whether in the 4.x and the 5.0 world, you need to think about how you want to allocate capacity to the multidimensional scaling. How many index servers do you want to have? How many data nodes do you want to have? How many query services do you want to have? So depending on your workload, you will need to make the right allocation. Alerting and monitoring. There was another great talk about how to set up monitoring using Nagios. Please make sure that you look at that. If you're going to operate Couchbase in the real world, that's an excellent way to start with. and an excellent way to augment whatever alerting that Couchbase provides out of the box. RAM allocation, obviously, as I said, Couchbase is a memory-first database. So you need to think about how your RAM, the RAM that you allocate, will drive your configuration, right? So the size of your cluster and so on. Auto failover, I'm not going to get into that. Auto failover is a setting which determines how quickly your cluster responds to a node going down, right? And how the replicas are going to be promoted so that the cluster comes back to a normal state, after which you need to do rebalancing. Auto compaction, I talked about. This is something that you can set at the cluster level, not at the bucket level, which is still a little bit of a problem. There's something called a metadata purge interval, where you might need to look at changing the default values. Another configuration parameter is the use of a read-only user. The read-only user is an admin read user, which gives you access to the statistics, right? So there are some role-based access control changes that are coming in 4.6 and 5.0, which will give you greater control over access to your data. So there are some hidden settings available in the REST API. So make sure that in addition to these configuration parameters that we sort of listed here, that you're able to look at the REST API as well. When you go deploy, you also need to understand whether you want to make a choice of using the cloud, which potentially most probably will give you a set of virtual machines, versus running that on bare metal in your own data centers. Both of them present two different sets of challenges, right? When you run this with bare metals, obviously you have greater control over the key value performance. You control the host names and so on, but obviously there is a cost to that. In the cloud, a lot of this work can be managed by layers that are provided by the cloud vendor. So two different things, for which you lose some flexibility. And the size of the SKUs that you will get there are normally lower than what you would have for bare metals. And as a result, for the same amount of capacity that needs to be hosted, the number of nodes is slightly higher on the cloud side, right? So plus and minus. Failure protection. We talked briefly about setting the number of replica copies. Normally, in a single cluster, I would recommend that you have an n+1 copy for protecting against n node failures. But make sure you don't go overboard, right? The maximum I've seen is 1 master plus 2 copies. More than that, you kind of have to think about whether you want to do that, right? I'm going to show in a subsequent slide a set of how we do multi-cluster failover, right? When you set up a multi-cluster, you potentially will need to do that if you want to operate in multiple data centers, or even within a data center, if that is your primary data center, you want to provide local data failover, right? Depending on how it is and how your networking is, you might want to do that. There is obviously overhead complexity issues when you set up XDCR. You also need to think about data quality. So when you're operating 2 clusters, each of them receiving writes, and if you have set up bidirectional replication, then there's going to be some data conflict. You need to think about how to manage that, right? You won't have this multi-data center active situation in a traditional database, because all these databases are like one single piece, right? When you go into the new world, this is a new challenge that you need to face and overcome. Another interesting question that always comes up is this a system of record or is it a cache, which is like a system of engagement? Now, Couchbase supports both. It's left to you to choose, right? So just remember that when you want to use an SOR, you need to have some supporting tools like ETL, the ability to extract this data, the ability to reconstruct data when something goes wrong, traceability for the data, as well as data quality for the data. Things are getting better in this NoSQL world. If you remember the 4x4 slide that I talked about, I said that this is an area which is still developing, right? So we're looking forward to maturity in this area. But keep that in mind when you make a decision about whether you want to use this as an SOR. Right, so multi-tenancy. So here is a problem, right? A bucket is a unit that can be addressed by a particular application in a Couchbase cluster. Now, when you have a cluster, how many buckets do you keep in that cluster? There is a practical limit, and there is a suggested limit. So out of the box, you can go up to 10, but the suggested limit is 4, and there is a reason for that, right? Number one, cluster-wide setting counts all buckets, so you cannot set that at certain things at an individual bucket level. The second problem, that's one of our biggest problems, is that a large number of client pools creates a large number of connections, and XTCR adds to that. So I have a simple animation to describe what it is. So this is a cluster, 2-node cluster with 1 bucket in there, 1 app. Every app has to connect to every node in that bucket, right? So let's say what happens to the number of connections when you add a application client, 2 more connections. What happens when you add another bucket? Some more. 3rd bucket, right? Now think about what happens when you add a node. Another set of connections have to appear, right? So there is an upper limit to this number, because every connection that you create is an OS process that needs to die and come up, and a node goes down and goes up, right? All of this takes time. So keep that in mind when you talk about availability and number of buckets being created in one single cluster. Rebalancing and compaction also has a lot of overhead. There's a fixed number of workers which need to do the rebalancing and the compaction, and they all go through 1 bucket at a time. So as the number of buckets increases, and even as the number of views increases, the number of workers sort of controls how long this rebalance and compaction is going to take. So keep that in mind when you decide to add other buckets into a cluster, right? So you also have a noisy neighbor problem, because there are 2 different buckets doing 2 different things, right? And there is mismatch in use cases and usage profiles. So keep that in mind when you talk about multi-tenancy of multiple buckets within a cluster. So data modeling, I'm going to skip a few beats here. Data is a critical piece in the system, and here is my favorite sentence. Applications come, applications go, data stays forever, right? So model your data carefully. So Couchbase out of the box is driven by sharding, right? So the choice of the key is critical. What is the key made of? Is it a GUID? GUID can give you a good way of spreading out all your data, right? Because it is sharded out of the box using CRC32. All 5 minutes? Okay, I'm going to, sure. So secondary key, I talked about a few problems there. So I'm going to not talk about logical data modeling and physical data modeling. This is something that you already know about. This is another sort of a table which describes the relationship between a relational database and a Couchbase data server. This slide has appeared earlier, so I'm going to skip this. I'm going to skip this too. And let me just walk you through this temporary generic use case, right? So I've taken up this generic use case of how would I use tokens or cookies using a Couchbase cluster. So let's say I have a load balancer, I have an app, I have a cookie service that I built here. I build a Couchbase cluster underneath this. So typically, this will have a large number of small items and have a high number of reads and writes. And you can set up cross data center XDCR and set up the same thing on the other side and use this load balancer and director to do traffic shaping, right? So cookies are server-side indicators. They reduce network chattiness. this is a use case, perfect use case for reducing network chattiness and creating server-side analysis capabilities for your cookies. So this is a perfect use case. Tokens. Tokens are typically used for login and other authentication. They have a high read-write rate, so they support keep me signed in. So if the token is not available in the cluster, you go to another token generator, you get that, put that in the cluster. This is a perfect use case for engagement, a system of engagement. And we talk about this as an engagement database, right? So this sort of use case aligns to that. So these are fairly long TTLs. They pretty much don't expire. So let's go to the next one. Configuration and a rules engine, right? So you have this same load balancer, apps, and you're talking to multiple services. Now, in these services, you might need to build in some rules about what the service can do, what are the limits to that service, and so on. Now, those rules, instead of keeping them in the service, you abstract them using a config and rules engine and use Couchbase as a way to store this rules engine. This is another use case, right? So this is typically slowly changing rules and configurations. It is very read heavy. It changes very, very rarely, right? But you need high availability. It is typically store forever with no TTL, but here is where you can add a client optimization, right? So if you add a L1 cache at the config rules engine, what you can then do is that you can offload all the reads away from the Couchbase server into this rules cache because it doesn't change often, right? But you can also build an updater thread which recognizes that, hey, this rule changed, so let me update my cache. And that can be eventually consistent. So this is key value. Data model is a key value with some secondary keys. You should provide the ability to do n-1, n, and n+1 versions, and that can be easily built. So let me go to the last one, which is system of engagement, which is a cache. You have this app service, the same thing, and potentially let's say that it was accessing an SOR, right? What we're going to do here is to say replace the access to the SOR, abstract that with a caching engine. You build a cache here in this side here, and you have this SOR. But if you want consistency from between the SOR and the cache, then you build in some mechanisms, right? So you can have a parallel read call, go to the consistency, go to SOR for a tracker table. The tracker table gets updated whenever the transactions changes, right? So if you do that, you have a very, very simple lookup to the SOR. You read the cache, you compare the versions. If they are right, then you return from the cache. If you don't have that, it's a cache miss, then you reconstructed that from the SOR. That's the only time you need to depend on the SOR for this reconstruction. So you offloaded a lot of work. So these are some of the characteristics. It improves availability, scalability, and headroom for the SOR. But depending on the consistency requirements, you may need to make sure that this cache consistency mechanism is being built. You can do a read buffering cache, which basically I described this. On cache miss, you have to reconstruct from the SOR. You can also create what is called a write buffering cache. So instead of writing to the SOR, you write to the cache and return back to the client, and then allow that another mechanism to read from the cache and write to the SOR. So cache, you need to be very careful to set a short TTL for the cache. Otherwise, you're going to overwhelm your cache with a lot of data, right? So typically, you engage with something, and then you have to forget about it. If the user comes to read the same again after it has expired, then you do the same cache miss, read from the SOR, and so on, right? So remember, when you have the short TTL, there is a lot of expiry. Now I'm going to tie you back from here to this compaction that I talked about. So this cache system will have a lot of compaction. It'll have a lot of transient data. So different characteristics. And when you do this, you need to think not only about the capacity for the RAM, for the cache, but also the effects of TTL and compaction, right? So this sort of wraps up some of the things that I was talking about. On the development side, there are choice of platform, there is out-of-box kits, there's tons of information available on the web. You just need to do a Google search to create this. But build in the client-side resiliency, right? I talked about how you can do failover from one cluster to another cluster. The good news is that Couchbase is coming up with a new version of the client where you will be able to specify 2 handles for a main cluster and a fallback cluster, and all of that will be handled at the Couchbase client library itself. So QA is important. You need to make sure that your QA also keeps up with your main versions. On the operation side, you got to standardize everything. And I have my past colleague, Shenglin, who's going to come and speak after me. He's going to talk about this automation and standardization. Operate in a DevOps mode. In this new world, as I said, the responsibility shifts over to the application side. So database admins and developers need to work together in a DevOps model to make this a success. And of course, you need to keep your community relations up, keep attending such Couchbase conferences and other meetups where you learn from each other and from vendors. We'd be glad to help you. Right? So putting it all together, this is the end of my talk. I hope I am on time, and hopefully we'll have some time for questions. Connect up with me on LinkedIn. I'm always there to share my knowledge. Thank you very much.
Yeah, we have time for questions. We have a few minutes for a few questions. Yes.
Yes, sir.
Yeah. Or you can holler. He'll repeat your question.
I think for a newcomer, there were a lot of knobs and whistles for configuring performance.
Mm-hmm.
Are there tools to analyze your queries and make recommendations for you for the tuning?
Sure. So let me repeat the question. Are there tools and knobs and other indicators to help you understand and tune the queries? Yes. So if you use the query, the nickel queries, there is a plan. You can display the plan. You can say which parts of the plan are taking what time and so on. Most of the talk that I was talking about is the key value side of things, right? In the key value, what you will get is indicators that you will have to build in on the client side. So on the client side, you have some logging to say, hey, I asked for this particular key at X point in time. I got this back at X.1 point in time. I summarize that over a period of time and see a client view of the performance. But you also have a lot of server stats that comes out, which tells you the number of operations per second. That is more throughput oriented. Latency checks you might need to build from the client side.
We have time for one more question.
Yes, sir.
Right here.
Full disclosure, so I work for Couchbase. So my question is, have you explored any of the new content in 5.0 and any comments on how it compares?
Yes, so the question is, have we explored 5.0? Yes, but we are not yet there. So we had previously a long tail of older versions that we had to pull in. It's really difficult. And this is feedback that you heard from everywhere else, right? If you have a large fleet, you have a large variation, a large drift. That is our problem number one. We need to make sure that the drift in the versions is kept as small as possible. This year, within PayPal, we put all our efforts into getting together and reducing that drift. Next year is when we will go into some of these new areas, hopefully.
Out of time, but thanks for everybody for joining us for the session. Thanks again, John.
Thank you very much.
We have another session starting in just 5 minutes. We're just going to swap out some laptops and get started into a session from Shenglin from eBay. So we'll be talking about self-managing clusters. So please come back or don't even leave.